Hello everyone, welcome to my class. Up to last class, we were discussed about amines, classification, nomenclature, and preparation methods of amines, physical properties of amines, basicity of amines, comparison of basicity of amines from alkyl halides and aryl halides, and basicity in order of primary, secondary, tertiary amines, and chemical properties of amines like reaction of amines with alkyl halides, reaction of amines with acyl halides, reaction of amines with HNO2, reaction of amines with Hinsberg reagent, oxidation reactions, reduction reactions, we were discussed. And also we were discussed about the what is phase transfer catalyst and also how to distinguish primary, secondary, tertiary amines from the mixture also we were discussing. So in this class, we are going to discuss about the diazonium salts, like preparation of diazonium salts, and many important chemical reactions are there with the diazonium salts, and all those we are going to discuss now. So first, what is diazotization? Diazotization is nothing but aryl amines reacts with the sodium nitrite in the presence of mineral acid, that is HCl, at low temperature like 0 to 5 degrees forms aryl diazonium chloride salts. This process of conversion from aryl amines to diazonium chloride is called as diazotization. And compared to this aromatic diazonium salts, aromatic diazonium salts are stable up to 10 degrees centigrades. Coming to the diazotization reaction, here this compound is aniline when it reacts with the sodium nitrite in the presence of HCl and in the presence of 0 to 5 degrees temperature, that means low temperature, this aniline which is undergoing to forms as benzene diazonium chloride. This is the benzene diazonium. N2 plus is called as diazonium. This is called as chloride. This process of conversion of aniline to conversion of benzene diazonium chloride is called as diazotization reaction. And coming to the mechanism of this reaction, as we already last class discussed about this mechanism, here aniline, which is also primary amine, when it reacts with the HNO2, that is nitrous acid, in the presence of sodium nitrate HCl, when combined sodium nitrate HCl, which forms the nitrous acid in the presence of 0 to 5 degrees temperature, which produces the benzene diazonium chloride. If you see the mechanism here, 2 moles of the nitrous acid will involve. So from here, OH minus eliminated, from here H plus is eliminated, and here this bonding electron shifted towards to the oxygen, so oxygen will get the minus charge. Now, so here, and this bonding electrons taken by the oxygen, so this nitrogen will get the plus charge. So here, one nitrogen will get plus charge and oxygen will get the minus charge. And here, this nitrogen will donate its electrons to this nitrogen because which is having the deficient. So by donating its lone pair of electrons to the nitrogen, which makes the bond between the two nitrogens, and which is donated electrons, hence this nitrogen will get the positive charge. Here, next in the next step, this is the aniline on the nitrogen, which is also containing the lone pair of electrons, which donates its electrons to here nitrogen. So simultaneously, this NO2 group will leave by taking its bonding electrons as NO2 minus. And here this nitrogen is donated its lone pair of electrons to here this nitrogen, hence this nitrogen will get the plus charge. Here to neutralize this positive charge, this nitrogen will take its bonding electrons, this hydrogen bonding electrons, so that here H is liberated as H plus and NO2 is liberated as NO2 minus. This H plus and NO2 minus combine together and will eliminate as a HNO2. And here, finally, by making the bond between this nitrogen and this nitrogen, this compound will form. Further, in this compound, here this nitrogen which is having one hydrogen which donates its bond hydrogen bond electrons to here. Simultaneously, this pi bonding electron shifted towards to the oxygen because here oxygen is a more electronegative atom than the nitrogen. So here this hydrogen shifted from here to this oxygen. This also called as a tautomerism, this process. So finally, this compound will form. So further, this compound on reaction with the acid. So here, oxygen, which is having the lone pair of electrons, which takes this proton. So finally, it forms the OH2 plus. Because this oxygen is having the plus charge, which is unstable, so which takes its bonding electrons, so which eliminate as a H2O molecule. And here this nitrogen which donates its bonding electrons to here and it forms the N triple bond N plus here because which is donated electrons, so which forms the N plus. And finally when it reacts with the Cl minus Na plus Cl minus, finally which forms the benzene diazonium chloride. So this is the mechanism of preparation of benzene diazonium chloride. So in the first step 2 moles of the nitrous acids will react. So from here OH minus, from here H plus will eliminate as a water molecule. This compound will form here by donating the nitrogen, its lone pair of electrons to this nitrogen, this compound will form. And in the next step, aniline by donating its lone pair of electrons to here, which forms this compound by eliminating here NO2 as NO2 minus and H as H plus, and this compound will form. Then here from this compound, this hydrogen will transfer from nitrogen to 1 to 3rd place. This process is called as tautomerism. Next, by reacting in the presence of the acid and in the presence of the sodium chloride, finally which produces the benzene diazonium chloride. So this formation of conversion of aniline to benzene diazonium chloride, this process is called as diazotization reaction. And from this diazotization reaction, in this diazotization reaction, the products are benzene diazonium chloride. With help of the benzene diazonium chloride, we can prepare different types of the aromatic compounds. That means this benzene diazonium chloride, which is having lot of synthetic applications. So let us see the synthetic applications of the benzene diazonium chloride. So first reaction, first chemical reaction, replacement of diazonium group by hydroxyl group. Here benzene diazonium, this compound is called as benzene diazonium chloride in the presence of the water. Here the temperature is nearly 50 to 60 degrees temperature. In this water is dissociated as H plus and OH minus. OH minus is a nucleophile. This OH minus, this because oxygen is having the lone pair of electrons, it gives its electrons to here, and this N2 plus is eliminated by taking its bonding electrons, which liberates as a nitrogen gas and Cl minus. So here generally this mechanism is a SN2 type reaction because here this nitrogen will eliminate by taking its bonding electrons, which eliminates here plus charge will form where OH minus group will substitute here. So this is the SN2 type mechanism. So benzene diazonium chloride when reacted with the water in the presence of heat, which produces the phenol. And next reaction, replacement of diazonium group by the cyano group. Here, as we are all studied this aniline by reacting with the sodium nitrate, HCl, 0 to 5 degrees temperature like 273 to 278 Kelvin, which produces the benzene diazonium chloride. And further, by reacting this compound within the presence of cuprous cyanide, this is the in this copper which is having the +1 charge, hence it is called as cuprous cyanide. Here in this one also cyanide is a minus charge and cuprous which is having the positive charge. So here this minus charge compound which gives its electrons to here, so simultaneously this compound eliminate as a by taking its bonding electrons here, this compound is eliminated as a nitrogen as well as Cl minus. So finally, which produces the cyanobenzene. So all these are the mechanism of the SN2 type mechanism, because here which is the nucleophile, cyanide is a nucleophile which substituted in the place of one nucleophile, hence this is also called as SN2 type mechanism and produces the cyanobenzene. And third reaction, which is very important, the name is called as Sand-Meyer reaction. In the Sand-Meyer reaction, replacing of the diazonium group with chlorine or bromine group. So here Sand-Meyer reaction is nothing but, as we all know this one, aniline when reacts with the sodium nitrate HCl in the presence of 273 Kelvin to 278 Kelvin, that is 0 to 5 degrees temperature, which produces the benzene diazonium chloride. So conversion of this aniline to benzene diazonium chloride, this process is called as diazotization. Now this benzene diazonium chloride on reaction with the cuprous chloride. In this cuprous chloride, again Cu is the +1 charge, which is a cation, whereas Cl minus, which is a anion. So this anion will be replaced with this diazonium chloride group and produces the chlorobenzene. And here this benzene diazonium chloride, when it reacts with the cuprous bromide in the presence of HBr, where Br minus will be replaced with this diazonium chloride group and produces the bromobenzene. So with the help of the Sand-Meyer reaction, we can prepare either chlorobenzene or bromobenzene. And next reaction is Gattermann reaction. This Gattermann reaction also very important as exam point of view. So here in this reaction also benzene diazonium chloride, so it react with the cuprous, which is a finely divided copper powder in the presence of HCl. So here benzene diazonium chloride, when it reacts with the copper powder, so here this copper powder is act as a catalyst. So when it reacts in the presence of the HCl, so in this HCl also H plus is a cation, Cl minus is a anion. This Cl minus will replace the diazonium chloride group and produces the chlorobenzene. So with help of the Gattermann reaction, we can prepare the chlorobenzene. Whereas with help of the Sand-Meyer reaction, we can prepare chlorobenzene as well as we can prepare the bromobenzene also. In the Sand-Meyer reaction, we are taking the reagent as a cuprous chloride or cuprous bromide, whereas in Gattermann reaction, we are taking the copper powder, which is acting as a catalyst. And in the presence of the HCl, here by using this reaction, we can prepare the chlorobenzene. And next reaction, replacement of the diazonium group by the fluorine. This reaction is called as Schemann's reaction. This reaction name is called as Schemann's reaction. So here benzene diazonium chloride on reaction with the hydrogen tetrafluoroborate, hydrogen tetrafluoroborate, by reacting with this here in this reagent, H is acting as a cation, H plus, whereas BF4, which is a anion. So by benzene diazonium chloride, first by reacting with this HBF4, this chloride, which is replaced by the BF4 minus, because here in this diazonium chloride also N2 plus Cl minus, this Cl minus will be replaced by the BF4 minus and produces the benzene diazonium fluoroborate, benzene diazonium fluoroborate, which is further on heating, in this BF4 minus, one of the fluorine which shift to here, and by replacing complete this group and produces the fluorobenzene. And here the byproducts are nitrogen and BF3. So here, so conversion of benzene diazonium chloride to chlorobenzene in the presence of hydrogen tetrafluoroborate, this reaction is called as Schumann reaction. And next reaction is replacement of diazonium group by iodide. So here benzene diazonium chloride on reaction with potassium iodide. In this potassium iodide, K is acting as a plus, which is a cation, whereas I is a anion. I is dissociated as I minus. So here this I minus also, this nucleophile will be replaced this diazonium chloride group. This is also example for the SN2 type reaction. So here this diazonium chloride group which eliminate by taking its bonding pair of electrons. So here nitrogen will eliminate as a neutral gas, as nitrogen gas. So by here this K plus and Cl minus eliminate as a KCl, and this iodide will be substituted here. So finally, which is also produces the iodobenzene. So by like this, by using this benzene diazonium chloride, with help of the benzene diazonium chloride, we can prepare all type of the halobenzenes. With the help of Schumann's reaction, we can prepare the chlorobenzene. With Sandmeyer reaction, we can prepare chlorobenzene, bromobenzene. With help of the Gattermann reaction also, we can prepare the chlorobenzene. And also with help of the potassium iodide also, we can prepare the iodobenzene. And next reaction is replacement of diazonium chloride group by nitro group. Here, benzene diazonium chloride, when it reacts with the fluoroboric acid, that is HBF4, or hydrogen tetrafluoroborate, are also called as fluoroboric acid. So here, in the first step, chloride, which is the nucleophile, this nucleophile which is replaced by the BF4 minus, because in this fluoroboric acid, H is dissociated as a H plus, whereas BF4 which is exist as a BF4 minus. So the Cl minus which is replaced by the BF4 minus, that is nucleophilic substitution reaction, and which is further reaction with the sodium nitrite. In the sodium nitrite, sodium is existing as a plus charge, whereas nitro group which is existing as a minus charge. So this NO2 minus group will be substituted by removing this group. So here also this nitrogen group will remove as eliminate as by taking its bonding electrons. Nitrogen will eliminate as a nitrogen gas, and here by taking this sodium group, it which eliminated as a sodium tetrafluoroborate. And finally, this nitro group will be substituted here. This is also nucleophilic substitution reaction like SN2 type reaction. And next reaction is coupling reactions or replacement by the, this is the replacement of benzene diazonium group by the aryl group. So here this is the benzene when it reacts with the benzene diazonium chloride in the presence of base. So here this base which is a OH minus, first this base will take this benzene proton as a H plus. So this H plus and OH minus eliminate as a water. So by removing the H plus plus here, this is it forms the phenyl anion. Now this phenyl anion is acting as a nucleophile. So this phenyl anion will be attack here by replacing the diazonium chloride. So by replacing this diazonium chloride group, it produces the biphenyl. It produces the biphenyl. And next reaction is coupling reactions. So here this is the benzene diazonium chloride, first coupling reaction with the phenols. So here which is compound is a benzene diazonium chloride when it reacts with the phenol. So here as we are all know, phenol, in the phenol, OH group is the activating group, that means which donates electrons to the benzene ring. So, which donates electrons to the benzene ring, hence at ortho position as well as para position in this phenol, which is having the more electron density. So here what will happen, because which is having the more electron density is nothing but which is having the minus charge. So here what will happen, it here from here H group and from here Cl group, which eliminates as a HCl and produces the here which produces the azodide, or which is this compound also called as para hydroxy azo. N double bond N is called as azobenzene. Para hydroxy N double bond N is called as azobenzene. So this compound is called as a dye. Similarly, in the same way, benzene diazonium chloride, when it reacts with the beta naphthol, which is also produces the azodide. So this is the benzene diazonium chloride when it reacts with the beta naphthol. So beta naphthol also called as 2-naphthol. This is the naphthol structure. So in this compound, OH group is present at 1, 2, second position, are also called as, this is position is called as alpha, whereas this position is called as beta. So this benzene diazonium chloride, when it reacts with the beta naphthol in the presence of base, that is OH minus, which is also produces the azodide. These two compounds are dyes compounds. So we here also at first position in naphthol, first position which is attached to the nitrogen and produces the azodide. These two are examples for the coupling reaction. So here this is the benzene diazonium chloride when it reacts with the phenol, which produces the para hydroxy azobenzene, whereas benzene diazonium chloride when it reacts with the beta naphthol, which is also produces the azodide. And next reaction is reaction with the aniline. This is also example of the coupling reaction. So here in this aniline compound also, as we are all know, any amine group is a activating group, is nothing but this nitrogen, which donates electrons to the benzene ring and produces the more electron density at ortho position as well as para position. Like phenol, aniline also, which is also activating group. So because of the activating group of this amine group, which is also having more electron density at ortho as well as para position. So here also, by removing here H plus and Cl minus as a HCl, and which is also produces the azo compound. This compound is called as para amino azobenzene. Para amino azobenzene. So these are all the few reactions of the benzene diazonium chloride. So next reaction is reduction reaction. This benzene diazonium chloride, when it reacts with the tin, SN is nothing but this is tin dichloride or tin chloride in the presence of HCl or sodium sulfate. So this is the reducing agents. Reducing agents are nothing but addition of hydrogen or removal of oxygen is called as reduction. Reduction is nothing but addition of hydrogen or removal of oxygen is called as reduction. This reduction process is completely reverse to the oxidation process. So this is the reducing agent. So in the presence of the reducing agent, so this diazonium group is converting into the hydrogen group. So wherever N triple bond N is present here, so which is converted into NH, NH2 by addition of the hydrogen molecules. So this compound name is called as phenyl hydrogen. So these are all few chemical reactions of very important chemical reactions of the benzene diazonium chloride. So coming to the summary of this topic, So today we have discussed about the diazotization. Diazotization is nothing but conversion of aniline in the presence of the sodium nitrate HCl 0 to 5 degrees, which produces the benzene diazonium chloride. This conversion of process of aniline to benzene diazonium chloride is called as diazotization. And also we have discussed about the mechanism of the diazotization. And next reaction is Sandmeyer reaction. We have also studied in the Sandmeyer reaction, benzene diazonium chloride, when it reacts with the cuprous chloride or cuprous bromide, which produces the chlorobenzene as well as bromobenzene. Next also we have studied the Gattermann reaction. In this Gattermann reaction, benzene diazonium chloride, when it reacts with the copper powder. So here this copper powder is which is acting as a catalyst. So in the presence of HCl in this reaction, which is also produces the chlorobenzene. Whereas in Schliemann reaction, so benzene diazonium chloride, when it reacts with the sodium tetrafluoroborate, which produces the fluorobenzene. Fluorobenzene. And here, this benzene diazonium chloride groups, which are replaced by the iodine, so when it reacts with the potassium iodide, so which produces the iodobenzene. And this benzene diazonium chloride, when it reacts with the base, that is OH minus, in the presence of high temperature, which is also produces the phenols. And this benzene diazonium chloride, when it reacts with the sodium cyanide, also which produces the cyanobenzene. And next reaction with the nitro group, that is benzene diazonium chloride, when it reacts with the sodium nitrite, so NO2 group is replaced with the diazonium group, so produces the nitrobenzene. So these are all examples for the SN2 type of reaction. That means in all these reaction, nucleophile is replacing the diazonium group and produces the different aromatic compounds. Next reaction, coupling reaction. In this coupling reactions, we have studied the benzene diazonium chloride when it reacts with the phenol, which produces the azodide, whereas benzene diazonium chloride, when it reacts with the beta naphtha, also which produces the azodides. And also we have studied the reaction with aniline, which is also example of the coupling reaction. So here benzene diazonium chloride, when it reacts with the aniline, so which is also produces the azo compound. In these, here the phenols and here the anilines, both are the activating groups. So electron density will be reached at ortho and para position. From the para position to benzene diazonium group, reaction will be taking place and produces the dice compounds. I hope you are all understood of the today's topic. So next class we are going to discuss about cyanides and isocyanides. So thank you for your patience listening.